Hello, everyone. Today, we're going to begin one of the most important topics in calculus: limits. Let's start with the definition. A function has a limit L as x approaches a value a, written as the limit of f of x as x approaches a is equal to L, provided that the y values of the function get closer and closer to the value L from both sides of a. Notice that a limit is concerned with what the function is approaching, not necessarily the value of the function at that point. For a limit to exist, three conditions must be met. First, the left-hand limit must exist. Second, the right-hand limit must exist. Finally, the left-hand limit and the right-hand limit must be equal. If all three conditions are satisfied, then the limit exists. We can determine limits from both the graph and the equation of a function. In this lesson, we'll focus on determining limits from a graph. When finding limits from a graph, follow these three simple steps. Start at the left side of the graph and trace toward the x value to determine the left-hand limit. Do the same from the right side of the graph to determine the right-hand limit. If the left-hand limit is equal to the right, then the limit exists. Let's look at our first example. First, we'll determine the limit as the function approaches 4. We begin by approaching 4 from the left, or the negative side. As we trace the graph toward 4, the y values approach 0. Therefore, the left-hand limit is 0. Now we approach 4 from the right, or the positive side. Again, the y values approach 0. Therefore, the right-hand limit is also 0. Since the function approaches the same value from both sides, the limit exists. So, the limit as x approaches 4 is 0. Now let's look at another example. This time, we'll determine the limit as the function approaches 1. First, we approach 1 from the left. The y value approaches 1, so the left-hand limit is 1. Next, we approach 1 from the right. The y value approaches 2, so the right-hand limit is 2. Since the left-hand limit and the right-hand limit are different, the limit does not exist. Remember, both sides must approach the same value for a limit to exist. Limits always exist for continuous functions, but they can also exist at holes, also called removable discontinuities, and at horizontal asymptotes. At vertical asymptotes, limits often do not exist because the function usually approaches positive or negative infinity. Limits are also useful for determining whether a function is continuous at a point. A function is continuous at the point EA, FA, if three conditions are satisfied. First, FA is defined. Second, the limit as x approaches a exists. Third, the limit as x approaches a is equal to FA. If all three conditions are true, then the function is continuous at that point. Let's try an example. We want to determine whether the function is continuous at x equals 1. First, we approach 1 from the left. The graph approaches -3, so the left-hand limit is -3. Next, we approach 1 from the right. The graph also approaches -3, so the right-hand limit is -3. Since both sides approach the same value, the overall limit is -3. Now let's look at the actual function value when x equals 1. The y value is also -3. Let's check the three conditions. The function is defined at x equals 1. The limit exists, and the limit is equal to the function value. Since all three conditions are satisfied, the function is continuous at x equals 1. Now let's look at one final example. Again, we'll determine whether the function is continuous at x equals 1. Approaching from the left, the graph approaches 1. Approaching from the right, the graph also approaches 1. Since both sides approach the same value, the overall limit is 1. However, when x equals 1, the actual y value of the function is 3. Although the limit exists, it is not equal to the function value. Because the third condition is not satisfied, the function is not continuous at x equals 1. Let's summarize what we've learned. A limit tells us the value a function approaches as x approaches a particular number. To determine a limit from a graph, always check the function from both the left and the right. If both sides approach the same value, the limit exists. Finally, a function is continuous at a point. If it is defined, the limit exists, and the limit is equal to the function's value at that point. Thanks for watching. Like and subscribe, and I'll see you in the next one.